The shopper pushes a grocery cart 20.0 meters at a constant speed on level ground against a 35.0 Newton frictional force. He pushes in a direction 25.0 degree below the horizontal. Alright, so what are we given here? Alright, shopper pushes certain distance, so displacement delta x is 20.0 meters. At a constant speed, velocity is constant. For change in velocity 0 implies that acceleration is equal to 0, and that in turn implies net force is equal to 0 because net force is mass times acceleration. And there is frictional force, and the frictional force is 35.0 newtons. Note the friction force is opposite against, therefore negative 35 newtons. Alright, the first step will be to sketch the situation, to sketch the motion. So if this is a cart, there will be friction force in this direction, and the force exerted by the shopper at certain angle from the horizontal downward, this angle here, theta. And theta is equal to negative 25 degrees because it's below the horizontal. This is a friction force. Cart has mass, therefore gravitational force is going to be downward. And the surface will act on the cart, and that will be a normal force upward. So mg and m, and then cancels out. There is no motion in a vertical direction. This is a positive x-axis. Alright, this is a free body diagram of the situation. Therefore, A is asking for what is the work done on the cart by friction, work of friction. And we know that work of friction is equal to the friction force multiplied by the displacement. F is minus 35. Multiplied by the displacement, which is 20 meters. That's equal to minus 700 joule. Okay. And that will be the work done by the friction force. B. What is the work done on the cart by the gravitational force? Work of gravity. Let's denote it by Wg. And Wg is equal to mass times gravitational acceleration times delta y. And there is no motion in the vertical direction. Delta y is equal to 0. Therefore, work done by gravity is going to be 0. C. What is the work done on the cart by the shopper? Work done by the shopper, let's denote it by W sub S. Alright, so we know that the net work is equal to 0. Therefore, W net is going to be the algebraic sum of all work done. That's work done by the shopper. That's work done by friction. That should add up to 0. This implies that the work of the shopper, work done by the shopper, is equal to negative work done by friction. Plug in the numbers. Negative of, we have calculated the work done by friction in A, and that's minus 700 joule. And that is equal to 700 joule positive. D, find the force of the shopper, or find the force the shopper exerts using energy consideration. So find F sub S. Alright, the work done by the shopper is equal to force in the x direction multiplied by delta x. This implies, because the horizontal component of the force F in the x direction is this one here. That's F cos theta, cos done by the shopper. Alright, so that's equal to, that implies work done by the shopper equals F cos theta multiplied by delta x. Alright, and this implies that the force done by the shopper is equal to work done by the shopper divided by delta x cos theta. Plug in the numbers. Work done by the shopper is 700 joule, as calculated in C. Divide that by delta x, which is 20 meters, multiplied by cosine of 25 degree negative. That's equal 38.6 newtons. So the force exerted by the shopper is 38.6 newtons. Alright, E, what is the total work done on the card? So let's denote it by WT, and that's what we are required to find here. And the total work done is equal to the sum of the algebraic sum of all work done. That's work done by the shopper plus work done by friction. Work done by the shopper is 700 joule plus work done by friction is negative 700 joule. And the sum is equal to 0.